All right, good morning, everyone. We're going to move on to our next section of inverses, and this time it's for exponential and logarithmic functions. Exponential and logarithmic functions are inverse functions. To prove this, we're going to find the inverse of the exponential function below and then graph the function and its inverse on the graph provided. So we have our parent function f of x equals e to the x power. So remember, even though we have e, and that's for exponential, the inverse of e will be natural log, which is still a logarithmic function as well. So we're going to identify the domain and range of this, and also kind of cover transformations as well. So for our domain, if we wanted to graph this, it would be all real numbers because it's still an exponential function. And then for our range, we have y is greater than 0 because remember we have an asymptote. So I'm going to go to my calculator so you can see it. We're going to type in e to the x power. We're going to graph it, and there we have our exponential function. Remember, we have a horizontal asymptote is y equals 0, and that determines that our range has to be greater than, not greater or equal to, because we never touch the asymptote. So even though it looks like our domain, our x values will get cut off, it won't. We will hit every single x value eventually. So we're going to go ahead and graph that where we have a y-intercept at 1. Okay, so there is my parent function of e to the x power. So now we're going to find the inverse. So remember, the inverse is log for exponentials. So we're going to rewrite f of x is y, and then we're going to switch places. When we take the inverse, we're switching x and y in its place. So we have x equals e to the y power. And then once we switch them, we're going to solve for y. So we're trying to get y by itself. Now, the inverse of taking the exponent or squaring something, or not squaring something, the inverse of exponential is log. And in this case, since we have an e, it's going to be natural log. So we're going to take the inverse of both sides. So natural log of x is going to equal the natural log of e to the y. And what's redundant about this is ln e is going to cancel out. So we have ln x equals y. And we have y by itself already. If there was a coefficient in the front, we would have to divide, or if there was something else, we would have to do that as well. So now we have our parent function. So f inverse of x equals ln x, and I'm writing this in parentheses. Okay, so now we're going to graph that and see what that one looks like. So I go to y equals. I'm going to put this in y2 so you can see what that looks like. So natural log, and then x, close our parentheses. We're going to graph it, and there we have that. Even though it looks like it stops at -1, it's actually going to keep going, because remember, these are inverses of each other. So when I graph it on this side, we have here, and it's actually going to go this direction. Because this time we now have a new asymptote, or asymptote here is x equals 0. So everything is flipped. That's why they're inverses of each other. So in this case, our new domain, we don't hit every single x value. It's now x is greater than 0, because everything on the right side of our x-axis or y-axis. And then our range is all real numbers, because we're eventually going to hit every single y value in this direction. So now let's do another example where we might have some transformations that will take place and how that affects our domain and range as well as its inverse. So for our first one, we have a transformation here. So we have e to the x plus 1. And so we have plus 1, and that's going to be a horizontal shift to the left. So now I'm going to go left 1. And now on the outside, we have -3, which means I'm going to go down 3. So that's just to cover some transformations, and that might determine what our function is going to look like. So I'm going to put this in our calculator. and then hit second graph, which gives us a table, but we want to go ahead and just look at the graph. Again, if you want to look at the other points, then that's fine as well. So we have a point. I can always go to graph table to see both. Okay, so I do have a point at -1, -2. Okay, and it is increasing this direction. It's still an exponential function. So now we're going to determine our domain and range of this one. So our domain is still all real numbers, but our range is now shifted. It's going to be y is greater than -3. Notice that our down 3, our vertical shift, also determines our new asymptote, which affects our range. Now that we've done that, we're going to find the inverse. So just like before, we're going to change f of x to y, and then we're going to switch x and y in its place. Okay. So the first thing I want to do is move -3 to the other side. I'm trying to get y plus 1 at least by itself first. So if I move to the other side, it becomes +3. And now we need to take the inverse of both sides. Now the inverse of e is natural log. So natural log of x plus 3 equals the natural log of e to the y plus 1. Now remember, what cancels out, or what's redundant, is ln e. So now I have the natural log of x plus 3 equals y plus 1. And we're wanting to get 1 or y by itself, so I need to move this one over to the other side. Taking the inverse of adding is subtracting. And I'm not subtracting from x or the 3. I'm subtracting from the entirety of ln x plus 3. So this means it will go on the minus 1 on the outside. So now our inverse is ln x, or natural log of x plus 3 minus 1. Okay, so now I'm going to graph this one. Okay, so natural log x plus 3 minus 1. Well, I grabbed a different calculator, so I don't have it on graph mode. So my dimensions are a little off, and that's okay. Okay, in the meantime, I know where these are supposed to go. So everything is flipped. So now means my new point, if the inverse of this one was -1, -2, that means the inverse of this one will be -2, -1. And then it's going to flip the other direction. So technically this is what this would look like if my calculator was doing what it was supposed to do. I will have to go ahead and change the dimensions, and I will do that another day on a different video. So now that we have our new one, remember, just like our previous for our parent function, our new domain, everything is switched. So if this was y is greater than -3, our domain is now going to be x is greater than -3. And our range now becomes all real numbers. Alright, let's do another one that doesn't involve e. We're going to do log. So I have f of x equals log x plus 2 minus 1. So based on our transformations, we know we're going to go down 1, and we're also going to go to the left 2. So let's put this in our calculator. So we have log, and this has a log base 10 on it. Okay, so this is what it looks like, and we have a point at -1, -1. Here's that, and we saw that it was kind of reaching this direction, not really approaching 0, but kind of, and then it caps off. Okay, so using this to the best of our ability. Our domain for our log function is x is greater than -2. Because this is a log, it's the inverse of exponential. So this has a vertical asymptote at -2, which was inside our parentheses. Okay, our range is all real numbers. Now that we've done that, we're going to actually solve the logarithm. We're actually going to write the inverse of the log function using a little bit of solving that we've done in a previous video. So we know we need to switch x and y. I'm going to go ahead and write x equals log parentheses y plus 2 minus 1, because we know we need to switch them around anyway. So I'm just skipping one prior step where f of x is y. So once we do that, we're trying to get log y plus 2 by itself, so I know I need to move -1 to the other side, and I'm going to add it since I'm crossing that equal sign. Okay, now we have a log y plus 2 on one side and x plus 1 on the other. So we're going to take the inverse of both sides. That's literally what this means. We're not solving it, we're just taking the inverse of it. I mean, I guess you could rewrite. You can do that as well. Or you can take the inverse of both sides and they will cancel out. So remember, if we're going to rewrite, which might help better for this, we know we have, or we're going to take the inverse. The inverse with this base has a 10, so it's indivisible. So we're going to do 10 to the x plus 1 equals 10 to log 10y plus 2. So log 10y plus 2 is the entire thing is an exponent. Okay, so once we've done that, we know what will cancel out is 10 log 10. That's going to cancel out. Again, you can also do this by rewriting as well. So now we have 10 to the x plus 1 equals y plus 2. Now we need to move 2 to the other side to get y by itself, and so that means I would have to subtract. And here I have my inverse function, where y is by itself. So I'm going to rewrite this as f inverse of x equals 10 to the x plus 1 minus 2. Now remember, the inverse of our points are switching x and y as well. So if this is -1, -1, the inverse is still -1, -1. So this actually becomes an intersection for us. Okay. Now we can also graph this as well, but due to time, we're just going to see it as is. Our domain is, remember, it is switched from here. So instead of our domain being x is greater than -2, our domain is now our old range, which is all our numbers. And then our range, even though it says range is all real numbers here, we're taking the inverse, which is the opposite of almost everything here. And so it would be y is greater than -2. Now on the back side, we're going to do some more examples on taking the inverse of exponential and logarithms, and then you'll be able to practice on your own. So our first one, I already have it pre-written. F of x equals 5 to the x plus 2. And I went ahead and switched to x and y, so we can go ahead and solve for that. Okay, so what I'm going to do is actually take the inverse of both sides, and the inverse of an exponential function is log. So this would become log base 5. So it wouldn't just be log, it would be log base 5 because this is the base. Okay, so if it becomes big 5, it's now little 5. And then we have x equals log base 5 to the 5 y plus 2. So what ends up canceling out is our log 5 or log base 5, 5. So that's going to go away. And so now we're left with log base 5x equals y plus 2. Now remember, we're trying to get y by itself. So that means I need to subtract 2 over to the other side. And then I have my inverse. Well, y is by itself. I'm just going to rewrite it where I have f inverse of x. And there we have it. Okay, let's try number 2 with e. Okay, remember, h of x is still the same as y, and we know we got to switch x and y, so I'm going to go ahead and put x equals e to the y minus 3 plus 4. So remember, we're trying to get x by itself. I'm sorry, we're trying to get y by itself, so I need to move 4 to the other side, so it becomes x minus 4. Okay. Then we're going to take the inverse of both sides. So unlike number 1 where we had log because we had a base of 5, this one we have base e, so we're going to use natural log. So natural log of x minus 4 equals natural log of e to the y minus 3. L and e is going to cancel out. So now I have the natural log of x minus 4 equals y minus 3. And again, we have one more step to get y by itself, and that is to add 3 over to the other side. Think of a lot of times when you're solving for your inverses or solving for y, your y's always end up being on the right, when normally when we solve for x or in other cases, the y is usually on the left side. So now we can rewrite h inverse of x, that's supposed to be an h, pardon my handwriting, equals ln x minus 4 plus 3. Okay, let's go on to number 3. Now we have solving, or I'm sorry, not solving, but we are using our prior knowledge of solving exponential and logarithmic functions to find the inverse. So number 3 says f of x equals the natural log of x minus 2 plus 1. So remember, we're switching our x and y. So now we know we need to subtract 1 to the other side. So x minus 1 equals natural log of y minus 2. Now remember, we don't have e this time, but we're going to use e in order to cancel out the natural log. And we're going to exponentiate both sides. So e to the x minus 1 equals e to the ln y minus 2. Okay, so these are inverses of each other. So you either take the natural log when given e, or you exponentiate it when given natural log. Okay, so e to the x minus 1 is going to stay, but e and ln cancel out on the other side. So I have e to the x minus 1 equals y minus 2. And then I know I need to add 2 to the other side to get y by itself. And now I have y, and my inverse function is complete. So I'm just going to rewrite it with f inverse of x. Right, our last example is f of x equals log x minus 3 minus 5. Okay, so remember this log has a base of 10 on it. Just remember that. It has a base of 10. So you need to rewrite it, and maybe we will this time with y log base 10 x minus 3 minus 5. And we're going to switch our x and y now. Okay. So now I need to get y. Oops, it's supposed to be a y. Y by itself, so I need to add 5 over to the x side. And then remember, the inverse of log is exponentiating it. And I wrote the 10 for a reason because that is our base. So now I'm going to do 10 to the x plus 5 equals 10 log 10 y minus 3. It's redundant for a reason because we're supposed to be canceling something out. And 10 log base 10 is going to cancel out. The goal is to get y by itself, so something must go. So 10 to the x plus 5 equals y minus 3. And we're down to one step to get y by itself, and that is to add. And so now I can write my inverse. F inverse of x equals 10 to the x plus 5 plus 3. Thank you so much for watching this video. If at any point this is confusing, I highly suggest going back to watching solving exponential functions and solving logarithmic functions. Thank you so much. If you have any questions, please feel free to contact me.